Yeah, wait, hold on. Yeah, the presentation mode. Oops.
I am recording, John.
Okay, you're recording.
Thank you so much.
Okay, and you can all see the lead-in screen, the intro screen.
Yep.
Yes.
Yep.
Okay,
We do.
so Corrinne got her BS in physics from anthropology at USC. She has lived in California, rural Hawaii, Colorado, Florida, upstate New York, and Oregon. She was also a foreign exchange student to Denmark and did a stint in the Peace Corps in Lesotho, Africa. Her career was mostly in healthcare insurance, but she keeps an interest up in anthropology. And would everybody, other than Corrinne, please mute your mics to keep the background down. And with that, I'll turn it over to Corrinne.
Hello, everyone. The title of this talk this evening is Neanderthals, Denisovans, Homo Sapiens, the Story of Us. Can you all hear me?
Again.
Okay. Our last evolutionary ancestors, the Neanderthals and the Denisovans. This morning's inauguration of a new president is about our future. This talk will be about our prehistoric past. I am glad all of you are here this evening. This has given me an opportunity for public speaking that I haven't had in quite some time. I have never done one of these Zoom meetings. Tonight, I'm going to be talking about what we know to date as our last evolutionary ancestors, the Neanderthals and the Denisovans. The telephone call. My sister called me a couple months ago and asked me if I'd heard about the Denisovans. She indicated that we, Homo Sapiens, had actually interbred with these hominids. Well, I had never heard of the Denisovans. I'm sure most of you haven't, and definitely didn't know about us modern humans interbreeding with any other hominid. This information definitely sparked my interest and started my quest to investigate this hominid group, the Denisovans. Anthropology versus archaeology. Though I was given an introduction prior to this talk, I would like to give you more details. I have a degree in anthropology from USC. Anthropology is defined as the study of man. It can be the study of human societies and cultures and their development, and/or the study of human biology and physiological characteristics and their evolution. So I know I might have disappointed a few of you thinking that this was going to be an Indiana Jones type story. Actually, this again is another common misconception. Indiana Jones was an archaeologist. Archaeologists study human history and prehistory through the excavation of sites and the analysis of artifacts and other physical remains. Hard versus soft sciences. We have the same methodologies. Though many of you have a background in the hard sciences that include things like physics, math, and chemistry, and that anthropology is considered a soft science. In actuality, these two types of science are not that different, as both sciences require testing and verification, and neither science is written in stone, as it is always changing with new facts. Sex. Question mark, hyphen. There is going to be a discussion about sex, or to sound more scientific, mating. So I might lose some of my audience here that are more sensitive, but I will not be showing anything pornographic unless you think a picture of Farrah Fawcett in a bathing suit is pornographic. So now I have lost the rest of my audience. Great, so I'm basically talking to myself. I remember going to a party a couple years ago. When we first meet strangers, it seems inevitable that they'll ask us about our years in the university and what we majored in. I said I majored in anthropology, expecting yawning and then a possible mention of Indiana Jones. But instead, one guy piped up and said, "So, you basically majored in sex." Well, I hadn't thought of that before, so I thought on that and indeed realized that that's exactly what I majored in. Evolutionary theory, not just a guess. I also want to dispel any misunderstandings as to why evolution is called a theory. I know many of you in my audience tonight are scientists and that you are well acquainted with the definition of theory. But I'm hoping this presentation is being videotaped so that I can send this to my friends and other people that may not be as familiar with the scientific definition of theory. In everyday use, the word theory often means an untested hunch or a guess without supporting evidence. But for us scientists, a theory has nearly the opposite.
Lost her. We lost you.
No, we lost her. She's muted. She went to mute.
Actually, she might have hit the.
Oh, all right.
What
I got it. No.
Okay, you're back. You're back.
You're back. We lost you at theory of.
A theory is a well-substantiated explanation of an aspect of the natural world that can incorporate laws, hypotheses, and facts. The definition of evolution is a change over time. It is the process by which modern organisms have descended from ancient ones. Evolution is referred to as a theory because it is a well-supported explanation of phenomena that have occurred in the natural world. I will be looking at the latter stages of human evolution, discussing how Neanderthals and Denisovans, our nearest relatives, have contributed to modern humans, us.
Guys, do you see like a menu bar at the bottom of your screen that's blocking the charts?
No.
Okay, good. Okay, fine. I do, but that's fine. No, it's not. Oh, why it's not going forward? Hang on. What the hell? Oh, there we go.
Yeah. There you go.
DNA today. Since graduating from college in the Pleistocene age, there have been many advances in the field of anthropology. Most importantly in this discussion are the advances of DNA sequencing. I will not be going into details of DNA sequencing and its advances. If after this talk, the subject of DNA sequencing interests you, there are loads of articles and books about the subject that you could spend the rest of your previous years reading. Or you could instead enjoy sex and attempt to pass on your genetic material to future generations. With the proliferation of genetic testing like 23andMe and Ancestry.com, all of us are becoming interested in genetics and the advances in DNA sequencing. We are realizing that some groups of people were isolated, such as people in the highlands of Scotland, and people with these ancestors may be able to locate the actual towns that their ancestors came from. Other groups were less isolated, so it's virtually impossible to know their exact geographic location, except for a very general geographic area. Okay, DNA mud bristling. When I was a student, much of what we know now was a mystery. We knew of our cousin, the Neanderthal, but we thought of this hominid as much more ape-like, with a brain much smaller than ours. With all of our technological advances in the field, we now know that their brain to body size ratio is much the same as modern humans. In this presentation, I will discuss another hominid, the Denisovan, that have just been discovered in 2008. The Neanderthal and Denisovans were the last hominids until modern human Homo Sapien reigned and stood alone on our planet. What has recently shocked and interested me is the scientific evidence that modern humans coexisted and interbred, had sex with, not only Neanderthals, but also the mysterious Denisovans. Timeline, the crossover. The story of our origin is constantly changing as new discoveries are made. In 2017, our history shifted by almost 100,000 years when a skull from Morocco became the oldest known example of Homo sapien, surpassing the 195,000-year-old record held by other remains in Ethiopia. It is now thought that there wasn't one single cradle of humanity and that early humans likely evolved in multiple places at the same time, all over Africa, and that we have much more to learn. That said, I have created a very rudimentary timeline to give you an idea of the time frame for when the Neanderthal, Denisovan, and Homo Sapien were alive. These times are not exact, and there is controversy surrounding them. But what I'm hoping to demonstrate is that no matter the argument on time frame, that there is no doubt in the scientific community that Neanderthals, Denisovans, and Homo Sapiens had crossover where they were all alive at the same time. So it appears from my timeline that Neanderthals ranged from 4,000 years ago, 400,000 years ago to 40,000 years ago. The Denisovans ranged from 200,000 years ago to 30,000 years ago. Homo sapiens, discovered in Africa, reigned from 200,000 years ago, in Southeast Asia, 100,000 years ago, and the Old World by 60 to 40,000 years ago. Rustling in caves. Sometimes the surprise is in the discovery of just how much we don't know. In 2008, a bone from a child's little finger was found in Denisova cave in Attila Mountains of Siberia. Few other bones were found, and it was therefore unclear whether the finger bone came from a modern human or from a Neanderthal. What's more, the deposits were mixed up, and it wasn't clear how or if the bones were associated with the stone artifacts also found in the cave. In the days before DNA analysis, Denisova Cave would have been just another archaeological site with little new to tell us. But the finger bone was sent to Pablo's laboratory at the Max Planck Institute for Evolutionary Anthropology in Leipzig, Germany, and our knowledge of human evolution changed forever. The first Denisovan individual was identified in 2010 based on mitochondrial DNA extracted from a juvenile female finger bone in Siberian's Denisova cave. Nuclear DNA indicates that they had close affinities with Neanderthals. The cave was periodically inhabited by Neanderthals, but it is unclear whether they ever cohabitated in the same cave at the same time. Additional specimens from Denisova cave were subsequently identified as a single specimen from Bashika Kursk cave on the Tibetan Plateau in China. Most recently, a home of a Denisovan was found to be 3,280 meters or 10,260 feet above sea level. Researchers were astonished to find ancient humans living at that altitude. Denisova spread. The Denisovans remains have been identified in mainly two locations. Traces of Denisovan DNA in modern humans suggest that they ranged across East Asia and potentially Western Eurasia. In 2019, geneticist Guy Jacobs identified 3 distinct populations of Denisovans in Siberia and East Asia, then one in New Guinea and nearby islands, in Oceania and a lesser extent across Asia. Using coalescent modeling, the Denisova cave Denisovan split from the second population about 283,000 years ago, and from that population about 363 years ago. This indicates that there were marked reproductive separations between Denisovan populations. Based on modern distribution of Denisovan DNA, Denisovans may have crossed the Wallace Line into Wallacea. This is a transitional zone between Asia and Australia, and also Saul, which is a transitional zone between New Guinea and Australia, with little back migration to west of that line. These Denisovans may have needed to even cross large bodies of water. Hundreds of Neanderthal skeletons, including intact skulls, have been found over the years, but the only fossils conclusively linked to Denisovans are a pinky bone from a young girl, plus 3 teeth, all from Denisova cave, as well as a recently identified lower jaw from China's Bashika cave. That individual's genome was published in 2010, and researchers quickly identified segments of Denisovan ancestry in several modern-day populations, most significantly with individuals from Oceania, but also in East and South Asia. Dating. Jacobs calculated integration, which is the transfer of genetic information from one species to another, or mating with another species. This transfer from the Denisovans to modern humans occurred about 29,900 years ago. A later date for a second population could indicate survival as late as 14,500 years ago, which would make them the latest surviving archaic human species. The Denisovan genome from Denisova cave has variants of genes which in modern humans are associated with dark skin, brown hair, and brown eyes. The Denisovan genome also contains a variant region around the AAAS1 gene that in Tibetans assists with adaptation to low oxygen levels at high elevations, and in a region containing the WARS2 and TBX15 loci, which affect body fat distribution in the Inuit. Denisovans versus Neanderthal, a beauty contest. Neanderthals had a long, low skull compared with modern humans, with a characteristic prominent brow ridge above their eyes. Their face was also distinctive. The central part of the face protruded forward and was dominated by a very big, wide nose. Their height was between 4'9" to 5'7".
Okay.
Very awesome. I have included a picture of Farrah Fawcett in my presentation. The reason for this is to point out that a genetic mutation found in Neanderthals contributed to her looks. Her blonde hair, blue eyes, light skin are all signs of her Neanderthal heritage. So if you have blue eyes or green eyes, if you have blonde hair, if you freckle and have light skin, you have some Neanderthal DNA. Now, doesn't that paint a picture different than the Neanderthal that you think of? Recent genetic studies have shown that Neanderthal DNA, spanning at least 20% of the ancient genome, survives in modern humans of non-African ascent. If you are European or Asian heritage, then about 2% of your genome originated from Neanderthals. You may have inherited some of the following characteristics from your Neanderthal relatives: an elongated skull, space between your wisdom teeth, suborbital ridge or brow ridge, broad projecting nose, little or no protruding chin, rosy cheeks, wide fingers and thumbs, straight thick hair, insulating skin, fair skin and freckles, red hair, large eyes, an immunity against Eurasian pathogens, an increased risk of type 2 diabetes, an increased risk of Crohn's disease, an increased risk of lupus, an increased risk of biliary cirrhosis, difficulty with nicotine addiction, an increased risk for long-term depression, just to name a few.
Doesn't sound good.
Denisovans. Because there are so few Denisovan remains found, we cannot conjecture as to their height. What we can say is that it appears that Denisovans resembled Neanderthals in many key traits, such as a robust jaw, low craniums, low foreheads, wide pelvis, wide forefingers, and large rib cage. But Denisovans were different than Neanderthals in that they had smaller shoulder blades, shallow hip sockets, earlier skeletal maturation, lower bone density. They had more space between their parental bones, more space between temporal bones, and a thinner face. They had a less protruding face, larger dental arch, and later tooth loss. Between modern human and the Denisovan, the differences are a large vertebrae in the neck, larger shoulder blades, more rounded long bones, thicker ribs, larger posterior vertebrae, larger pelvis, deeper hip sockets, longer and wider hip bones, larger hand bones, wider fingertips, later skeletal maturation, and higher bone density. Since the current study is based on a single individual and the technique only returns relative measurements, research cautions that it's an imperfect reflection of what the species or what the species actually look like.
Subspecies?
Hominid
Interbred.
hominid origin. Analysis of modern human genomes show a past interbreeding with at least two groups of ancient humans, Neanderthals and Denisovans, and that such interbreeding events occurred on multiple occasions. Comparison of the Denisovan, Neanderthal, and modern man genomes has revealed evidence for a complex web of interbreeding among these lineages. In Eurasia, interbreeding between Neanderthals and Denisovans and with modern humans took place several times. The integration events into modern humans are estimated to have happened with Neanderthals about 47,000 to 65,000 years ago, and with Denisovans about 44,000 to 54,000 years ago. As much as 17% of the Denisovan genome from Denisova cave represents DNA from the local Neanderthal population. The Denisovan genome shares more derived allies with the Attila Neanderthal genome from Siberia than several locations that Neanderthal DNA were found. Denisovans apparently interbred with modern humans, with about 3 to 5% of the DNA from Malaysians and Aboriginal Australians, and about 7 to 8% in those from Papua New Guinea deriving from Denisovans. Integration into modern humans may have occurred as recently as 30,000 years ago in New Guinea, which, if correct, might indicate that this population persisted as late as 14,500 years ago. There's also evidence of interbreeding with local Neanderthal populations, with about 17% of the Denisovan genome from Denisova cave deriving from them. A first-generation hybrid, nicknamed Denny, was discovered with a Denisovan father and a Neanderthal mother. The Denisovans weren't just genetically distant on the evidence of a huge molar teeth also found in the cave. They would have also looked and behaved quite differently. Perhaps 600,000 years ago, the lineage that led to modern humans split from the one that led to Neanderthal and Denisovans. Then about 400,000 years ago, Denisovans and Neanderthals themselves split into separate branches. Denisovans range from Siberia to Southeast Asia and may have persisted until 30,000 years ago, based on their genetic legacy in living Southeast Asians. It looks like the Denisovans actually had two branches, individuals from Oceania and individuals from East Asia, as they're uniquely different. What is known is that the Oceania individuals, notably the people in Papua New Guinea, have significant amounts of Denisovan ancestry. The genomes of modern people from Papua New Guinea contain at least 5% Denisovan ancestry.
Wow.
Okay, I think we already. Okay. Wherever I lay my hat, that's my home. A 2011 study found that Denisovan DNA is prevalent in Australian Aborigines, near Oceanians, Polynesians, Fijians, East Indonesians, and those from the Philippines, but not in East Asia, Western Indonesia.
Are we off on this?
Yeah, I think we're a little off.
So here's some of the bad stuff, some more
Right.
details. Is this what you want, Corinne? We'll go to the disappearance. What's next?
Yeah, let's see. The Denisovan genes may have helped modern humans.
Well, I don't know what that one is. You got bad stuff. You got. I believe you're still there. Talk about the good stuff.
Okay, Denisovan genes may have helped early modern humans migrating out of Africa to acclimatize. The distribution pattern and divergence from other allies involved in their immune systems, natural killer cell receptors, has led to the suggestion that it introgressed from Denisovans into modern humans in West Asia. Genes related to phospholipid transportation, which are involved in fat metabolism, and to that trace assisted receptors involved in smelling are more active in people with more Denisovan ancestry. And then this one doesn't really come, we don't have this. Anyway.
All right, well, here's some of the bad stuff we got from them. Here's some more detail about the bad stuff.
Right.
And why don't you go on to the, here's the bad stuff.
What does it get you? Is it
Why did it disappear?
disappear.
How did it disappear?
Okay.
okay? Wow.
Hey, can I ask you a question?
Sure.
So, supposedly, like my wife got 1 to 2% Neanderthal, right?
Yeah.
So you can get the red hair and the freckles and the eyes just with that 1 or 2%, huh?
Yeah, gene mutation. And so, obviously some things need both parents, like blue eyes need both parents to, have that mutation, but it's a mutation that was found in Neanderthal genome.
Yeah, and that's why Cindy's blonde and blue-eyed and tall. She's
Yeah.
Neanderthal.
Can you show that map again?
What map?
Well, you keep
Well,
going past it. And
I'm actually kind of interested in those pendants. That's pretty amazing.
Oh,
Yeah,
Yeah.
we'll get to that. Okay, get to that. That's
1 to
what it
2%. This one,
There,
this one.
there.
Ah.
is. Pendants, yeah.
Oh,
This is incredible.
right, yeah, these are some of the tools.
This is very sophisticated tool making right here.
Yeah, except remember, they lived they only died out, what, 30,000
Right,
years
years
ago?
ago.
And you even said 14,000.
Right.
I mean, if you go to the National Museum in Israel, you'll see the first human carving that's dated like 55,000 years ago. So,
Right. But this
I
is
don't know.
really, really detailed stuff here. This is pretty amazing. And these pendants are about 30,000 years old.
I don't think we know.
I just found a nice picture.
Yeah,
that
we just
talked
saw a
about
picture on
Denisovans.
Oh, sorry to get you off your subject. I'm sorry.
Why don't you cut the wires?
Okay.
No food. Let's go to wires.
Plenty of time, so just get,
No big deal. This is
Um,
great.
Denisovans disappeared, or Neanderthals disappeared about 40,000 years ago. Denisovans coexisted and mixed with modern humans in New Guinea until at least 30,000 years ago. Right, but as John said, perhaps as recently as 25 years ago. And so that means that the Denisovans were the last known humans, save ourselves, to walk the earth. So I'd like to talk about the eulogy to our ancestors. Now let's talk about what looks like an extinction of the Neanderthal and Denisovan. I'm gleaning information from an article in Sci News. Neanderthals were stocky hunters adapted to Europeans' cold steppes. Their enmatic cousins, the Denisovan, inhabited Asia about 10,000 years ago, and by then they were all gone. But there's no obvious environmental catastrophe, volcanic eruption. Indeed, we don't see any ash from the remains found. There wasn't, at that time, known any climate change, asteroid impact driving this. Instead, the extinction timing suggests that they were caused by the spread of a new species around 260,000 to 350,000 years ago in southern Africa, the Homo Sapiens. And I'm going to argue that I'm going to turn to history and examples of people warring and displacing and wiping out certain groups over territory, from Rome's destruction of Carthage to the American conquest of the West and the British colonization of Australia. There have been recent genocides and ethnic cleansing in Bosnia, Rwanda, Iraq, Darfur, and Myanmar. Like language or tool use, the capacity for and tendency to engage in genocides is arguably an intrinsic, instinctive part of human nature. There's little reason to think that early Homo sapiens were less territorial, less violent, less intolerant, and less human. I would like to first point out that Neanderthals and Denisovans were hunters and gatherers. Because they relied solely on what can be gleaned from the local environment and what it can support, their groups were smaller. They typically lived in extended family groups of no more than 20 to larger bands, no more than 200 people. I'm going to share a personal story here. As we mentioned before, they were hunting and gathering people. The only hunting and gathering society that I've had the opportunity of visiting were the Yanomamo in northern Brazil. It may help that one of the major anthropologists, Napoleon Chagnon, studied them and called them the fierce people. When I visited the Yanomami, I met the chief of the village. With my interpreter, I was able to communicate. The chief asked me, "How do you think I became chief?" I thought about this, as many chiefs become chiefs due to either inheritance or good hunting skills. He said no, that he had become chief after killing the previous chief. Romantics have painted early hunter-gatherers as peaceful, noble savages and have argued that our culture, not our nature, creates violence. But field studies, historic accounts, and archaeological evidence all show that war in primitive cultures was intense, pervasive, and lethal. Neolithic weapons such as clubs, spears, axes, bows, combined with guerrilla tactics like raids and ambushes, were devastating. Violence was the leading cause of death among men in these societies, and these wars have caused higher casualty levels per person than World War I and World War II. Neanderthal skeletons show patterns of trauma consistent with warfare. Sophisticated weapons likely gave Homo sapiens a military advantage. The arsenal of early Homo sapiens probably included projectile weapons like javelins and spear throwers, throwing sticks and clubs. Complex tools and culture would have helped us efficiently harvest a wider range of animals and plants, feeding larger tribes and giving us a strategic advantage in numbers. Old bones and artifacts show that this violence is ancient. The 9,000-year-old Kennewick man had a spear point embedded in his pelvis. The 10,000-year-old Naturuk site in Kenya documents the brutal massacre of at least 27 men, women, and children. It's unlikely that other human species were much more peaceful. The existence of cooperative violence in male chimps suggests that war predicates the evolution of humans. The ultimate weapon, but cave paintings, carvings, and musical instruments hint at something more dangerous, a sophisticated capacity for abstract thought and communication in Homo sapiens. The ability to cooperate, plan, strategize, manipulate, and deceit may have been our ultimate weapon. But why would our ancestors wipe out their relatives, causing a mass extinction, perhaps more accurately, a mass genocide? The answer lies in population growth. Humans reproduce exponentially. Unchecked, we historically double our numbers every 25 years. Once humans become cooperative hunters, we have no predators. Without predation controlling our numbers and little family planning beyond delayed marriage and infanticide, populations are to exploit the available resources. Further growth or food shortages caused by drought, harsh winters, or over-harvesting resources could inevitably lead tribes into conflict over scarce resources and foraging territory. Warfare became a check on population growth, perhaps the most important one. It looks like mating with other human species may have aided Homo sapiens' success. Studies of organisms ranging from finches to oak trees have shown that hybridization with local species can help colonizing species flourish in novel environments by giving them useful genes. Homo sapiens may have been the last hominid standing, but it got a leg up from its extinct ancestors. But the incompleteness of the fossil records makes it hard to test these ideas of what may have contributed to the extinction of early hominids. But in Europe, the only place with a relatively complete archaeological record, fossils show that within a few thousand years of our array, Neanderthals vanished. Traces of Neanderthal DNA in some Eurasian people prove we didn't just replace them. After they went extinct, we met and we mated. Do we have time for the video? Now in conclusion, is a video to recap the information that I presented.
It's from the American Advancement of the AAAS.
Flanked by sheer cliffs, has long been a worship site for Buddhists. Over the past 10 years, it has become a hotbed for scientists ever since a mandible fossil recovered from the cave captured the attention of a group of archaeologists. Their new paper confirms that the cave holds DNA from a group of ancient human relatives. 10 years ago, DNA analysis of fossils first thought to be Neanderthal, found in Denisova cave in Siberia, turned out to belong to a previously unknown relative of Neanderthals and humans. Scientists called them Denisovans. This hominid group spread its genes into the DNA of living humans now scattered as far as Papua New Guinea and Australia. Denisovans might also be the source of archaic DNA in modern Tibetans that aids oxygen absorption in high altitudes. Located roughly 3,200 meters above sea level, Baishia Karst Cave makes a likely resting place for Denisovans and the DNA they contributed to modern humans. Crack detective work by archaeologists led them to the excavation site. They followed the breadcrumbs from the mandible fossil, stored at a university in northwest China, to the cave, where a Buddhist monk reportedly stumbled upon the ancient lower jaw in the 1980s. In 2019, a new method of analyzing ancient proteins determined the jaw probably belonged to a Denisovan, but more DNA evidence was needed to settle the matter. Quickly, the excavation site proved rich in archaeological remains, including bones from long-extinct hyena and rhinoceros species. This emboldened researchers to hunt for definitive evidence of past Denisovan life trapped in the cave sediment. The researchers divvied up the cave sediment into 10 layers. From each of 8 layers, they extracted 100 to 250 milligram sediment samples, using molecular baits to fish for mammalian and human mitochondrial DNA, which is inherited along maternal lines. Layers 2, 3, 4, and 7 were found to harbor DNA of ancient hominids. After minimizing contamination from modern humans, it was determined that 70 to 100% of the DNA matched that of Denisovans, leaving the researchers with no doubt that Denisovans inhabited the cave. A special optical dating technique helped pinpoint the likely age of the DNA. It scoured single grains of sediment for varying exposure to light over the course of millennia. This identified Denisovan DNA as old as 100,000 years and as young as 60,000, and portions of some grains hinted at DNA as young as 45,000 years, not long before modern humans appeared in the region. The seminal research at Baishia Karst Cave bolsters evidence of widespread Denisovan habitation in mainland Asia, and the success of the sediment sampling technique could encourage similar investigations at other archaeological sites. It also speeds up the race to discover Denisovan nuclear DNA and fossils at the cave. Doing so would close the gap in science's understanding of how Denisovans and modern Tibetans are related, expanding our knowledge of human ancestry by reaching beyond mitochondrial DNA's matrilineal limits. It's a literal manhunt. A cave on the northeastern side.
Okay, that's it. Any questions for Corrinne?
Whoa.
Sure, I have a question. Can you hear me?
Yeah.
Yeah, okay. So first, thanks for the talk. I really love the variety of stuff we hear on these things. And as a physicist, I just thought that was fascinating to hear about that. So I really like that. And then, so why Homo sapiens 1? And you kind of said something similar to what I'd read in Sapiens, that the ability to imagine and things like that and work together is why we defeated these other. But I guess so why is it they didn't have that capability? Were they just not as smart as Homo sapiens, or do we know why they didn't have the same level of imagination? Is there a biological reason, or any ideas on that?
It's an excellent question. And I have a theory,
Tell your theory.
my theory, so when I heard about Einstein and that his brain was actually the same size as us average people, but he had more neurological connections and those connections were closer together when they analyzed his brain. And unfortunately, these fossil records do not preserve, neurological connections, so we can't know if Homo sapiens, if we Homo sapiens have an advantage. There could also be some genetic problems. I know that one area of the Denisovans, there was a genetic mutation on the Y chromosome, so there weren't any males being born. So actually the Denisovans in that area had to interbreed with Homo sapiens, or, they would not have survived. So, there could be also some, like in this talk talked about that the Homo sapiens were able to get some of the good, some of the genes from Neanderthals, that had, developed for thousands of years.
Okay, good. Well, it's good to know at least I was afraid we were just more brutal than the rest of them, and I'd rather be this winner because we're more intelligent rather than we're just more evil.
That's only speculation. We really don't know. I'm just speculating.
Thank you.
That's only speculation. Actually, Scott, there's a seminal paper on that, and the guy that discovered that is named Jeff Murphy, Greer Murphy, and he's the brother of our best man. And he's at your college, Stanford. He's a PhD he's a professor at Stanford.
So I'm going to get back to the pendants. Were they found in that cave? Were they actually found in that cave?
Yes.
And do you know what levels they were found at? Do you know? Okay.
But they wouldn't be showing those. So those were,
that's a significant cultural.
So the assumption is that where they found the Neanderthal bones, they also found these artifacts.
And were they bone, or were they organic, or were they bone, or were they wood?
Yeah, this was pre any it had to be bone. I mean, we didn't have metal.
Right.
It would have to be ossified bone, right?
Yeah,
Maybe.
fossilized.
It'd have to be turned into stone because bone doesn't last that long, is it?
Well, 30,000 years.
Unless it's frozen. I don't know.
Yeah, I do a lot of construction, and I have no decks that I've built that have lasted 30,000 years, so it couldn't have been made out of wood. So,
Exactly.
could I ask a question? The Y chromosome, it's interesting you brought that up, because the Y chromosome, being a male, depresses me in that it has no chance to recombine. So the Y chromosome that we have is the same as our great-great-great-grandfathers, without any chance of recombining or changing. And the fact that you say it ran out in the male Denisovans is interesting, because
to an extent that it mutated so that they weren't up, they couldn't produce any more males because they didn't have the Y. I mean, they had this mutated Y chromosome that wasn't working, right?
So it was a little bit like the Handmaid's Tale, except between two species. Now, my question though, they couldn't have been a different species at the time that we interbred, because species by definition can't interbreed.
Okay.
Isn't that right?
The reason I use species, but the information I gleaned from the said species, but you're right. Their definition of species is different than what we learned in school, and they.
Yeah, and it would be the same with Neanderthals. They were more like maybe a race, or
Right.
than a species. So, yeah, okay.
Interbreed, we could interbreed and have viable offspring with Neanderthals, Denisovans, right?
So
Even-
I was joking with Bruce the other day that when your daughter came home with a guy and you said he was a Neanderthal, then he really was a Neanderthal. He could have been a real Neanderthal.
Oh, he could not be. No, there are no Neanderthals walking the earth. Now he could have, some, up to 5% of his genes could be Neanderthal genes, but he's not.
No.
He'd probably be blue-eyed and blonde-haired.
Right, blue-eyed.
We're talking about 50,000 years ago. And if he had blonde hair, it wouldn't be anything like what we see today when they talk about it. But, and my final question is depression in Denisovans. Do you know if is there a particular gene that they link to this? I know there's a few genes that are supposedly related, but.
They're linking depression to Neanderthal. Now, again, we have a lot more Neanderthal bones, a lot more genetic material from the Neanderthals. We don't have very much from the Denisovans. So we don't really know. Denisovans, all we know is that the Tibetans and a smattering of Han Chinese have an advantage in terms of adapting to high altitudes through the Denisovans. So that gene is a Denisovan gene where they're able to handle higher altitudes. But that's the only, because we have such a small sample of Denisovan, that's the only thing we know,
Okay.
firmly that the Denisovans contributed.
So is that a different gene than like the people of the Andes in South America? Because those people are generally left out when we talk about genetic maps.
Right, yeah. No, yeah, they've been left out of what I found too. Yeah, they didn't talk anything about.
I know French Canadians have a high prevalence of a gene that's involved in serotonin synthesis. And I'm just wondering if maybe they got it from the Neanderthals, and it's the methylene tetrahydrofolate reductase gene. Do you know what that is? Do you know what it is in the Denisovans?
No, I don't know that specific, but it sounds very, very likely because the Neanderthal genes are ones that have adapted to, northern cold climates. You think of that kind of thing, and that's what Neanderthal had contributed to us.
Very cool. I'll check into that because I'm wondering where that gene came from and if there's a reason, is there a good reason to have a poor methylene tetrahydrofolate reductase? So I'll check into that for you.
Yeah, and some of these adaptations were good in the particular environments that these people lived in. For example, the Neanderthal, more northern with less sun. And, now we're in sunnier, climates like you and I, and, that's why we, probably have skin cancers and that kind of thing more prevalent because, our Neanderthal gene, ancestors didn't need, protection against the sun.
Yes.
That's what we do.
All right. Thank you.
Well, this interbreeding that we've been talking about, it's really amazing that three different groups of that were physically different and culturally different intermingled, which is absolutely unbelievable. But it could be interspecies. I think it may be interspecies. I know that may go against scientific definition, but I mean, it's sort of like a thoroughbred horse and a Arabian horse, intermingling. But
well, species do different species do interbreed.
Yeah, they do.
Yeah, it's basically how the science has defined them. You see different kinds of squirrels that interbreed that are considered different species. So the idea that species can't interbreed is not right.
Are the offspring non-sterile? I mean,
no, just in like donkeys and mules and stuff like that. But
For
lots of different.
Bruce.
Yeah.
Yeah.
It's just a fact. Yeah.
All right.
But culturally, they were all hunters and food gatherers, which is so there's. Huh.
Yeah.
Okay.
I'm wondering,
fascinating talk. I had one sort of thought about the extinction. I thought I had read that early on in the human population, Homo sapiens, I mean, by early on, I don't mean your dates, I mean 2,000, 3,000 years ago, the population barely survived, given low nutrition, early mortality, long birth intervals due to long lactation periods, that the population growth rate was very, very slow. And this combined with interbreeding in small numbers, if there were some, you could sort of see how the Denisovans might have just gone extinct, or if there's slightly less growth rate, slightly lower, and as you said, maybe groups of 25 and human groups are of 100, you'll get domination from hunting, but you'll also just get domination in the interbreeding. And I'm just, I just had trouble believing that in the times of very low nutrition and infectious disease killing people and all things that real populations were not doubling every 25 years then, the way that one thinks it might occur now. I thought it was much slower.
That's all speculation. I don't know. I know that Homo sapiens had larger groups. So Homo sapiens somehow, adapted larger groups than Denisovans. So yeah, they're going to have some advantages in genetics, because they're not going to be interbreeding so much and passing on the same, dysfunctional genes. So, that was definitely an advantage that the Homo sapiens had, right, over, the Neanderthal.
Yeah. And a small advantage in intelligence, letting you recognize your group versus other groups. Again, you get a bunch of multipliers and you gain a little bit each year over 30,000 years.
Right. And then we can get into the adaptation of like agriculture, which I think that was about 25,000 years ago, right?
Right, but that was Homo sapiens.
That was Homo sapiens, exactly. But that may have given them an advantage culturally and organization-wise,
Oh, definitely. But see, they needed the larger groups, to have the agriculture. Right. You can't really have specialization with such small groups,
Exactly.
Yeah.
I have a question. Did I understand correctly that the concept was that the male I always called it Denisovans. I know you're pronouncing it differently, but did they lose their Y chromosome? Because I thought that what happened was there was all this interbreeding, and if the interbreeding with the more advanced species, if you want to use that word, was passed on to the male children that resulted, so that it was not so much that they lost it, but that it was replaced eventually.
No, it was actually a genetic mutation on the Y chromosome.
Okay.
No, it didn't have anything.
Because now when they look back, it's really, that's the one that stands out, is that it's so much more like the males now, Y chromosomes than what they would have expected. And so I thought it was more a question of replacement. I don't know. It was in Science magazine that I read it not that long ago, but.
Well, from what I read, it was a genetic mutation.
Genetic. Okay.
Yeah.
Genes all the time are mutating, and most of them are not advantageous. Right. And if you have a small population, then you're really going to have problems there.
Do we know how long they lived?
I'm sorry, what?
Do we know how long the Neanderthals or the Denisovans lived?
I didn't look at that.
Their age, you mean?
You mean how old they usually live till?
Yeah. one of the reasons I ask is because some of your pictures, they look like they were 80 years old. I didn't think primitive people could live that long.
No, say no.
But if you got skeletons, you should be able to date them.
I just haven't read anything about, you know, I don't know what age they lived. I mean, like I said, you know, I kind of look at, it's not so much their genetics that I'm looking at. You know, you can look at hunting and gathering societies like the Yanomami, and yeah, they don't typically live really old because, you know, life is hard. You know, they're having to hunt and gather and walk long distances, and you know, these old people, they almost kind of give up because they want the rest of their group to survive, and they just kind of walk out in the you know, jungles or wherever and just kind of die because what is she talking about?
No, we saw that in the Yanomamos. Go ahead. I didn't want to interrupt.
Right. Like, you know, they're just, you know, not used to being old, and you know, when you're old, you're just not as productive, and you know, with a limited food source, you just can't, you know, have a lot of people that aren't producing.
They think it may be in the 30s and 40s. I can't remember where he was found, but there was a Neanderthal, pretty complete skeleton, I think, found near Lebanon. And they estimate that he was about 40 years old. He had a skull fracture that had healed. He had a withered right arm, they think, from an injury. And so he was taken care of. And there is evidence that that Neanderthals took care of injured. There's also evidence that they had a great many injuries. And two theories. One is that they hunted large animals. The other is that they fought. We'll never know, but they tend to have a lot of damaged skeletal structures. But this particular Neanderthal was about 40 years old and had several physical handicaps.
What did his teeth look like? I've had
Not
a pet thought that we live only as long as our teeth, because then our nutrition goes
No,
bad.
his teeth actually were pretty good. If anybody lives in Denver, and when the museum opens, we have the skull at the Denver Museum of Nature and Science, and his teeth are in good shape. His skull fracture is quite evident.
You do, right? So their teeth
I read something maybe a couple weeks ago that said 100 years ago in this country, the expectancy for men was 47 years.
Right.
So in the last 100 years, we've done much better. But I would expect that if you went back thousands of years, that life expectancy would have been like 25 years. Things were rougher. There were no buses.
And there were no antibiotics.
Yeah.
Right. Oh yeah, I saw that in Nepal. Yeah, I talked about the antibiotics. You know, this little girl came up to me and her finger had gangrene, and, you know, from obviously a cut that, you know, had, you know, not been treated. And, you know, she saw that I had a big, medicine bag, and, you know, asked me to, you know, help her. And obviously I couldn't, you know, I'm not going to cut off her finger. I don't have that expertise, but no, life was harder, you know, more pathogens, and, you know, like I argued in my paper, warfare, you know, they're, you know, one tribe was killing the other tribe. You know, they weren't peaceful, you know, we can't romanticize that they're peaceful people. I mean, when you look at the Yanomami, like I told you in the discussion about the chief, I mean, that's a real thing.
Also, just an aside, we talk about age. For those people who may be into paleo diets, do recall these humans didn't live much past 35 to 40. Just bear that in mind as you think about your diet.
That's an excellent comment. Yeah. Right.
Stay away from speed.
Good, some great questions. I love it. I love that you guys are thinking, and yeah.
So can we take a second to talk about next week? Next week, is Ed still on? Ed's gone. Anyway, Rick Schumann is going to come back and talk to us about, give us an update on vaccines next week. So probably want to see that. That should be pretty interesting. He's going to talk about the four main vaccines that are likely to be approved, and he'll tell us the differences between them and effectivity and whatnot. So that should be
Those of us that are new, is the Zoom address the same?
Yes. Yeah, there's a couple things you should know. Attached to every one of these signs for the boards, when we send it out, there is an attachment there that has the
attachment
YouTube link. Okay. Yeah, it has the YouTube link and it has the Zoom link. If you pop that thing open at 6:30 every Wednesday, right? You have to basically open the talk as if you're opening a PowerPoint. You can click on the Zoom link and it will work. What happens is most people just, they open it, they don't turn it into presentation mode. You have to go into presentation mode, basically. So once it's in presentation mode, all the links work, all right? And you won't have to fumble through all your emails if you just keep that on your desktop. Do you understand what I said or not?
Yes, thank you.
Oh. Usually the link is right in the text of the email.
Yeah, it's pretty
You
easy.
just click on that and we're there.
But if you get 75 emails, some people, they basically can't find the email anymore. So,
That's the thing. That's the one on the right, on the left lower, left on the schedule. Is that
Yeah.
correct?
I also put the link in your calendar.
Thank you for this presentation. I really enjoyed it today.
Oh, good. I'm so glad. Thank you.
Okay, bye.
that was amazing. That was really, really fun. It was less intimidating than some of the some of the stuff it was really hard.
I just put those emails in one directory, all the ones for upcoming Zoom. And when it comes up for that time, I go to that directory and there it is.
That's what I do.
So if I leave it in my inbox, you're right, I'd never find it.
Yeah. But what I wanted to say was the YouTube link is the one that's on there. That I don't put that on every. I don't send that out every week. Okay, so if you want to look at the YouTube video on anything, you can put that PowerPoint into presentation mode and click on the YouTube link. Okay, that's all.
Yeah, I want to.
Bruce, thanks.
Thank you.
Great meeting.
Good night, everybody. Thanks, Corrinne. Let's give her a hand.
It's fun.
All right.